Okay, well, thank you for joining the class this afternoon. Today, I'm going to go through basics of methods and functions in Python, and then I will introduce the Numpy library to you. Now, Numpy is fundamental to machine learning, or technically deep learning at a later stage, especially that it overlaps perfectly well with TensorFlow. So it's really good to start with NumPy and have a good understanding of how to use and implement it. But first we will go through some basics of functions so that you become more comfortable with it. And then I will introduce NumPy, and then we will do some practice with functions and NumPy sort of methods. Okay? So let's look into Python functions. What are they? So there are many built-in functions. We already know that there are functions in Python that we use, for example, the print function, or list function, functions that are built into Python and they do stuff for you. So there is an option to build your own functions specifically. Okay, so when you want to sort of have a specific process, you can define your own function and get your program to do that for you. Okay, in other words, they allow you to create code that can be executed easily without needing to repeat yourself. Basically you embed your code within a function, and then it just makes your life easier when you're trying to repeat the same code. Right, guys, can you put your mic on mute, please? Yeah, when you're speaking. All right. So how do we define a function? It's quite simple. You start with def. So I'm going to write it here. And make sure, guys, you have your notebook ready and running. So as much as you can, try to code along with me. So to start a function, you define, you def, def, that's the command. You give a space, and you give your function's name, yeah? Func name. And then you have closed parentheses, colon, and there we go. This is basically the point where you are initializing the function, yeah? So that's the syntax that you would use. The function that obviously you choose whatever name you want to choose here, but it starts, in the first instance like that. All right. So let's go ahead and make some actually functions, like to see how they work. So let's make a function that when it's called, very simple function. I mean, like this is vanilla sort of illustration of functions. So define, let's call it funky. Okay, that's it. And all it's going to do is to print hello. Yeah, super simple. Okay, so I just defined the function, called it funky, and all it does is that it will print hello when you call it. So how do we call this function? So here, if I call funky, okay, and of course I use parentheses, that's it. I mean, this is a really, really super simple function. Okay. To call the function, you just call the name and the closed parentheses, yeah? And then the function would follow the protocol, the lines that you have given it. But also pay a careful attention. Right after defining the function, please take a notice of the indentation, yeah? So notice the indentation. Very important, okay? Highly important that you understand that when you define a function, you def function name, close parenthesis, column, and you indent the next line and next lines, okay, however much you want to code, having an indentation with respect to the definition of the function. All right. Also, let's look at this, yeah? Maybe I can do that later. Right. So this function, define function, we did it, and then it was print hello. But you can also write define and funky, and this time instead of saying print hello, I'm going to say return. Yeah, return hello. It's very important right from beginning that you understand the difference between this print and return that I'm using. So I did that again. So I'm going to call funky now. Okay. Try to see the difference between the outputs. Yeah. So here you have hello. Obviously it's lower case because I put it as lowercase. But look at this. The output of this function, let me call them. Guys, can you put your mic on mute, please? Yeah. Okay. So if you notice, when I defined, let's just call it funky one. So funky one, and I'm going to just make this hello as well to be on the same side. And when I call funky one, I'm getting hello, but pay attention to the output. Funky two, okay, and return hello. I'm gonna call funky two. I'm getting a hello, except that this hello is a string. Okay, there's a big difference. What you're getting out here is just a print within this notebook environment. So the output is not saved or anything. Whereas with this, it's actually outputting a string. Okay, it's actually outputting a string. Now the difference goes to this, yeah? With the option where you put return, the value or the output of the function can be saved. Okay, here the output of the function can actually be saved. Okay, whereas in the other case with print, you're just getting a basic print output in this environment, nothing else. What do I mean by that? If I say A equals funky one, okay, A equals funky, sorry, it is funky one, isn't it? Let me call that, okay, and I'm going to say B equals funky 2, all right? Now let's call A, which is the print version, okay? Do you see what happened? A, it just gives you some, perhaps something that doesn't make sense, or just a repeat of the structure of the function. What if I give B? Okay, B should, oh my God, I should have done that, sorry. So if I do that, you see I still got the hello. If I do that, there is no hello out, yeah? So this is, let me just write this. This is with the print, and this is with return, okay? So A, if I call it, I'm not getting anything outputted. If I call B, I'm getting string hello. So B is actually equals to hello. The return does that. So the return enables you to output, to save the output of the function. Okay, you're able to save it. So it's very important that right from beginning you understand this difference. And most of the time, 99% of the time, when you do functions, you would use return and not the print statement, because that enables your function to have a functionality. Okay? Anyway, let's just move forward a bit and now make the function a little bit more interesting compared to this basic form. So, for example, I'm going to now enable the function to have an argument. Yeah, so here, this function is going to take an argument. Okay, this example. So I'm going to define it as define funky2, let's say, define funky2. And what I'm going to put here is parameter name, okay? Okay. Sorry if the kids are screaming in the background. All right. And I'm going to say print in this case for this function. And I'm going to use f string. We have covered this before. Hello. Okay. And I'm going to use name. Okay. So this function is now going to be a little bit more involved. It's still pretty vanilla, but I just want to build the momentum gradually. Okay, so I created this function. What does it do? What if I go and say funky2, just like, you know, we did it before. So funky2, there we go. Oops, we get an error. And as usual, when I always say, when you get an error, the first thing you do, go and read this, yeah? What does the error say? Funky2 is missing one required positional argument, okay? Meaning that this function expects an input, a parameter that needs to be fed into it, which is name, because that's how we have defined it. Without that, it would generate an error, okay? So that means we need to give something in this. So I'm going to say funky 2, and I'm going to say Ali. Okay, so now I'm getting the output hello Ali. So what does it do? The input, the parameter that we are giving to the function is incorporated within that f string print statement. Okay. This is just basically mixing the function and a basic print with f string statement. So as you have seen from the example exercises that I sent you, this would get become significantly more involved. Okay. But it's very important that you understand the concept behind it, okay? That how these functions ultimately work. Shall we go by now doing some basic math, with the functions? So I'm going to say, let's do some math, yeah? Okay. So let's do a function that, I don't know, returns the cube of a number, okay, as is present in this slide. So I'm going to say define funky3. And this function is going to take in a number. We're going to call it x. Obviously, you can put anything you want here. Yeah, it doesn't matter what you put there. And then it's going to return to us, return x cubed, for example. So I'm going to run this. So now if I call funky 3 and I give a number into it, it's going to output 729, which is 9 cubed. And I can also save a value to it. So I'm going to say C equals funky 3, and I'm going to put 9. Okay. Obviously now I don't see output, but that's because now C is assigned, is basically is saved as number 729. Okay. Again, pay attention that this is because I'm using the return. I would not have been able to save it as C if this was a print function at the end. Sorry, guys. Yeah. Hi, guys. Can you hear me? Can you hear me, guys? I think I got disconnected. I don't know what happened. Is that fine? Can you hear me? That's okay. I'm going to bring it back on. I don't know what happened. Is it okay? Is all okay? All right. I do apologize. I don't know what happened. It just basically shut me off. So, okay. Let me see if it's recording okay as well, just to be sure. All right, cool. All right. Yeah, I'm sorry. I don't know what happened, but let's just move on. So that is again, like doing some basic math. Now, I'm not going to repeat this because when we go to NumPy, I will bring more examples for you. Also, the number of parameters that you can give. So how many parameters we can incorporate into the function? Well, the answer is as many as you like. Okay, really, that's what you can do. So what does that mean? I mean, I'm going to define funky 5, let's say, yeah? So define funky 5, and this is going to take argument A, B, okay? Obviously, when I say as many as you like, so you can be A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, go all the way and create whatever you want. Obviously, when you do nobody does that because you only add these parameters dependent on what your function wants to do and what you intend to do. So there is no limit, okay? But obviously it's limited by what you need. So as many as you like, but technically you use as many as you need rather than just, putting these arguments here for the sake of nothing. So return, okay? We're going to return just a to the power of b. Okay, so this function enables us to give a number and give two numbers, and it would return the first number to the power of the second number. That's all it does, right? So if I say funky 5, and I'm going to give 10 and 10, okay? It's just going to return that value for me. And as usual, as before, we can assign it, save it. Notice here that I just used two arguments basically, because this equation, this function is designed to return the first number to the power of the second number. All right. Now, when I share these slides with you, well, I think I already have. If I haven't, you will get the whole entire slides of this Python course today, right? Which will have these codes available, so you can go through them. Obviously, you will see there are more stuff in this slide when I give it to you. You don't have to learn all of it, but I would say up to the point where I'm talking about functions, yeah, I'd like you to go ahead and sort of see it and practice it, especially if you're new. But throughout the rest of this course in future weeks, we'll be constantly using functions. I mean, when you learn Python or any other programming language, building functions is going to be your basically breakfast and lunch and dinner. So we will be experiencing, building these functions in multiple forms and shapes in future. But definitely have a look at these slides to ensure that you basically understand the idea of functions. So there are some examples here. Go ahead later on your own time and practice them. For example, in this function, I've now incorporated a for loop, and I'm using if and else statements. Okay, so I'm not going to type it here, but I'm going to just go through this one, for example, with you, describing it to you. And what I'd like you to do is that later on when you watch it, if you're still struggling, try to listen to the video and then have a sense and logical sense of what's happening. So as you can see here, we have, let me make this just a bit bigger because I'm focusing on there. Okay. So we have three lists. Yeah, we have a list A, we have a list B, and we have a list C. List A contains basically 5 numbers, 1, 2, 3, 4, 5. List B seems to have 3 numbers, and visually you can see they're all odd numbers. And list C is 3 numbers, and they are all even. Okay? So we want to check, we want to define a function, and we're going to name it odd checker. Well, or whatever name that you desire. And once you define the function, you see that it takes an input, a parameter, item. Now you could have put this as x if you liked. Yeah? You could have named this x, y, or anything that you think you like to name it. Right after this function, right after defining the function, I'm initializing some variable called k. Well, I'm initializing it as 0. Okay, so right after that, I'm saying k equals 0. All right, nothing so exciting. We go to the next line of command, and again, pay attention. It's indented. All of these lines are indented with respect to definition of the function. So they go under the umbrella of this function. Then I start a for loop. For I in item, okay, for I in item, this is a for loop. If the residue of dividing I by 2 equals 0, meaning if for I in item that I is even, k equals k plus 1. Update k. So suddenly the k that was initialized to be 0 is updated and becomes 1, because 0 plus 1 gives you 1. Okay, so it will do that. Yeah. If k, look at that. So it runs through the loop. It runs through the loop first, filling this. Yeah. So it will run through every element that is in that item, and every time it sees an even number, it updates k. So k would ultimately get updated dependent on how many even values are in this item that we are feeding into the function. Now, if k is bigger than 0, print this is a f string, yeah? Now k is updated after this, yeah? Just look at the indentation lines, guys, yeah? So this if runs after the for loop is over, okay? If k is bigger than 0, print there were k even numbers in your list. Else, print all numbers are odd, okay? So in a sense, this function is designed to take in a list or some item that is iterable, yeah? The moment that you see for I in items, it means that this function, you're going to be basically, you have designed it to take in an iterable, iterate through it, and check for even numbers. That's what this is doing. So when we call the number and we give list A, which is that, if we loop through it, so look at the function, odd checker list A. So instead of item, we are basically giving list A. So it will iterate through list A, and every time it sees an even number, it will update k for that instance, and ultimately would report the number of k, what's the value of k, if it's bigger than 0, meaning if he has found the even number in there. So it says 2. There were 2 even numbers in your list. Odd checker, we give list B. Well, list B are all odd numbers. Obviously, it's not going to find anything there, and it's going to be printing all numbers are odd. And if we go to C, obviously you should be finding 3 numbers, yeah? So I went through this explanation, and I really, really hope that you go and, try to code this yourself. If you made a mistake or you struggled, look at the code, see where did you make a mistake, and become really comfortable with this indentation process. Let me see. All right, map, filter, and lambda expressions. Because I want to cover NumPy with you today, I'm thinking to address this another time. or let's do the map as well, just so that we are basically safe, so you understand what this mapping is. What is a mapping of the function? So mapping functions. In future, like as I said, we'll be doing loads of these, so gradually you will get to learn these. But a good short, vanilla touch on it would be a good idea. So we're going to define this function called power. So define power, and power takes what? An argument, we could call it num, and it will return num to the power of 2. It just squares whatever you give it. That's what this function does. So if I say power 2, it should give us 4. What if I have a list? Okay, so let me make a list just like that. So my list equals 1, 2, 3, 4, 5, 6. Okay, can I go and say, all right, that was really good. I put number 2 and it gave me the square of number 2. Now that I have a list, let's just go and do power and power what? Power my list. Okay, you get an error. Again, golden rule. What do you do? Straight away you go and try to read this. Type error, unsupported operand types. Ooh, list and int. Okay. Now this is now the sort of error that is you're not easily able to sort of understand it. Yeah. Here you can use online resources, or like you can click on explain error to try to see if it makes sense. But right from now we can tell what's the problem is. This function is designed to take in a single number. Once it takes in a single number, it just squares it. It's not defined to take a whole list, which is a different data structure compared to a single integer, and like return a square of those elements. To do that, yeah, we use the map function. Okay, so instead of that, so I'm going to put here, oops, wrong way to do it. Well, not that. That definitely is not wrong. This is wrong. Okay, so the right way is that you use the map functionality. So if I say map, and I'm going to call my function, which is called power, yeah? Or function was called power. And I'm saying map this function to my list. Okay, let's see what do we get. First instance, you might be thinking, good God, is that some other form of error? Did I just make a mistake? Well, no, you haven't. But instead, all that has happened is that you need to save this at something. This is at the moment going to, it's basically referring to some memory location in your computer, yeah? So what you need to do, you need to name it as something. And we are going to say func map. Let's just go consistent with the slide. Equals map. Let me just change this. Let's just call it W, okay? Because I thought like if I use func map, some students might get confused that, oh, do I need to put a map at the end of the name? No, you don't. It just is a name that you give. So it's going to be a map of power and my list. Okay, so if I call W now, oh, my bad. Right. Did that solve your problem? Still, it's referring to a memory location, because like we thought, like if we give it a name, that should work it out. So what's the solution? Now let's look. Look at that. This is quite interesting, yeah? The reason for this, let me just see if I've put the note here. notice. It's important to use a loop, a for loop, to extract the results from the map. Yeah, because it creates the map when it's applied on a function and something like a list. Basically, it creates an object that needs to be iterated to extract the stuff from it. So you cannot just go and name it or just run it like that. Yeah. Rather, then you need to have a for loop to be able to extract the stuff out of it. So you need to do for I in W, and I used the capital, I think, didn't I? Yeah, I think so. For I in W, print I, okay, and it does that. Now, again, when I say I like you guys to use your own initiative, you might be like, all right, how do I just, I want a list. Why do I want this to be printed out here? Okay. So you just create empty list, empt equals that. Okay. So I just created the empty list, empt dot append I. Okay. So if I now come and say my list first, so what was our list? And if I call empt, oh, that shouldn't happen. What happened? That happened. Where did I go wrong in this? So I'm just running the loop and right, didn't expect to get this error. Let me just see if I've filter. I haven't brought it up here. All right, let me just for I in W. W is that, isn't it? So I've already drawn the W. Okay. All right, just leave it with me. I will sort it out in a bit. Let me just get the time. Okay, I will address this later for you, right? Let me just see what else do I need to do. The filter. I won't bother with the filter for the moment. I think I would give you. All right, I will show you a very basic lambda expression, but maybe at present I don't really want you to go into that. I'd rather leave that for a future. Yeah, leave this for future. I'd rather go into the NumPy since I really want you to have NumPy basically sorted for today. And okay, let me take a note of this, sorry guys, so that I can come back to it later. So I'm going to take that here and then shift enter. Right, so I'll leave that right now. Go. Sorry? What, wait, was it okay for you? I don't know what did I'm just, I don't know whether I'm like, let me just see. So say again, it's because for I in W, here's some. Let me just see. All right, let's just leave it. I don't know like where I'm going wrong with this, but that's fine. It's okay. Just leave it for the moment. Let me see. Do I have this right? 2, 3, 4. All right, I'll try to cover as much as the NumPy that I can for today. Now, NumPy, guys, if I
finished my work.
Okay, sorry, that was my daughter distracting me. Let's just put it. All right. So NumPy, what is NumPy, guys? Extremely important for you to understand what NumPy is and what it is used for. Ultimately, everything we do with deep learning, machine learning, and data science, many of the libraries, such as TensorFlow, okay, or scikit-learn, that we will get introduced to later, the data type, the data that they take in is ultimately matrices and arrays, okay? Like we had before, we had my list, yeah, and my list was 1, 2, 3, 4, 5, 6, okay? So that's my list, and if I go type my list, okay, the type of this data is a list, okay? Now, a NumPy array, while it would look similar to that in appearance, in first appearance, especially to a beginner, in terms of its data structure, it is not actually a list type. It is completely different under the bonnet, yeah? So what I'm going to do, I'm going to say import NumPy as NP, all right? So what I'm doing here, I'm importing NumPy as NP, so I am importing the NumPy library, abbreviating it as NP for shortcut, okay? Because, and that by convention you do the NP, because then when you want to call methods and all that, it just, NP is shorter than NumPy itself. So we have now imported NumPy, which means we can use the features associated with NumPy to write rest of our code. Let's look at that, what I was starting to say. So my list was 1, 2, 3, 4, 5, 6, yeah? Now, if I go and say NP, which is the NumPy, and then I'm going to call dot array, okay? And as an argument to this function, so dot array, it means I'm calling the NumPy, and I'm calling using the dot function, yeah? Which function? Array function. NP dot array, and I'm gonna feed my list into it, yeah? I'm getting that out. Now, in the first instance, you might be like, oh, what's that? It's an array of a list, array list. What is this? Like, so if I come and just say, copy and let's paste. If I say, I don't know, b equals that, yeah, right? So if I call b again, obviously it's going to be an array, but then what type is it? What is b? You see that the type, when we did the list and we did the type, it was type is list, yeah? Now we are getting a NumPy array. Being a NumPy array, then consequently enables you to call in other methods and other functionalities that would enable you to utilize this data form, for your machine learning or deep learning applications. All right. Obviously, I don't know, many of you would know it or not, but as I said, matrices and vectors are fundamental forms of data that a machine learning model takes in. Technically speaking, in mathematics, we should be calling them tensors, and these are tensors with different shapes and dimensions. But just to keep it simple, let's say vectors and matrices, yeah? So it's important for you to sort of try to grasp the difference, yeah, right from the very beginning, yeah. So what we created here at the moment is a single vector, okay? Now, what if we want to have a matrix, basically, yeah? So let's look at the structure. So I'm going to say my matrix equals, and I'm going to open bracket, and I'm going to go 4, 5, 6, and I'm going to have 7, 8, sorry, 7, 8, 9. All right. Okay. Now, technically speaking, guys, this is a list of lists. Yeah. So my matrix is a list of lists. Yeah. And if I just do quickly type my matrix, okay, it's a list. Now, if I call the array function from NumPy, so np dot means calling the array function and feeding this my matrix into it, it's going to convert this into a matrix. But please pay attention. So when you gave a single list to it, it takes in that list and converts it into a vector. But when you give a list of lists, it will convert it into a matrix. Now, if I had something like this, yeah, 1, 2, 3, 6, that's okay. It's still my matrix is a list. But would this work? Nope. You get an error. Why do we get an error? Setting an array element with a sequence, the requested array has an inhomogeneous shape after 1 dimensions. The detected shape was 3 plus inhomogeneous part. It's referring to this, you know. I know sometimes these terminologies and terms it uses is the least basically helpful method of explaining to you what the error was. The very fact is this: a matrix has a particular shape or dimension, okay? So you can have a matrix where it's 3 by 3, 2 by 2, 4 by 4, n by n, or m by n, yeah? It doesn't necessarily have to be a square. But when you are technically feeding it with this 1, 2, 3, 6, it has 4 elements, while the others have 3, okay? So either the others need to have a relevant element to be matching with this, or it's not going to work. So it's important that when you want to create a matrix like that, the dimensions are matching, okay? So definitely practice with this so that this idea sinks in. So this is a list of lists. It doesn't have any error in terms of its character. This is just a list of lists. We can put anything into it, so long as your idea of using it is just using it for as a what do you say, just as a list, yeah, or list of lists. But if it is to be used to be converted into a matrix, you need to pay careful attention that things need to match with each other, sizes and shapes, yeah. So let's just go back and eliminate that. Okay, so we just created a matrix in there. Now if I move forward, let's look at the arrange function. Yeah, so these are like the handiest stuff that you that comes with NumPy, and you should really become familiar in using and utilizing them. Yeah. So what is the arrange function? np.arrange 0, 10. Okay. You can tell it basically arranges numbers from 0 to 10. Okay, not including 10, of course, here. But pay attention, it doesn't create a list of numbers. Okay, so that's why just the reason I say this. Please pay attention that the output is not a list. It's a NumPy array. Okay, very important to understand. So all these NumPy functionalities, when you ask them to do things or give outputs, their outputs are always NumPy type data. which is pretty good actually. Well, it technically should be as well, because like for your machine learning or linear algebra objectives, you want to be dealing with data types that are treated like vectors or matrices. So NP arrange, a very useful function that you need to become familiar with. Then we got the np dot zeros. Okay, np dot zeros. Let's just give it 4 of them. All right. np dot zeros. It just created a vector of zeros. All right. And if I say np dot zeros, five by five. Okay. np zeros, look at the parentheses and the comma, the shape, or let's just give it like so that. So this is now creating a matrix of zeros, a zero matrix. What is the size? So when we gave just a single number, it creates a vector with elements equal to, in terms of how many they are, to the number that you feed in here. When you do zeros and you want to create a matrix, you give the number of rows first, followed by the number of columns. Okay? And that basically generates this matrix of zeros for you. Now, it is possible that you suddenly would be like, oh, why would I want to make that? Yeah, what is the functionality or use of a matrix of zeros? In fact, you will notice that this in future would be extremely, extremely, extremely important. It's very handy. It would be a fantastic tool for a lot of things that you would do in future. All right. At present, it may just seem something, irrelevant or dull, basically, just making a matrix of zeros. But what I want you to, for the moment, remember is that there is these functionalities that you can create a vector of zeros or a matrix of zeros. Okay. For the moment, that would be sufficient, so long as you become comfortable and familiar that it is possible to do this. Now let's look at something else. Okay, np1s. So np dot ones. Okay, and I'm going to put 3. So it creates a vector of 3 elements, all of them 1. And I can guess you can imagine np dot ones. And we're going to just repeat what we did before. Was it 5 and 3 I gave? Forgot. What was it? Yeah, that's correct. I do apologize. By the evening, I think I've become so tired I even forget what I put here by the time I get there. All right, np1s, and it just gives you a matrix of 1s. Okay? Can we do 2s? I've put it already in there, so it's not like np2s, 3 by 3. Well, definitely not. No, you can't. Yeah, so it's not like they have created it for you to go 3s, 4s, 5s, 6, hundreds. You can just do 1s and zeros. Yeah, but if you really need, because you might, yeah, if you need a matrix of 2s, it's pretty simple. All you need to do is to do np1s, and you just do a multiply by 2. Yeah. And you get a matrix of 2s. If you matrix of 200s, the same thing goes by, yeah? And no need to mention, you don't do np zeros multiply by anything, because you still get the zeros, since it's every element is 0. So if this would, for example, in terms of functionality, maybe I shouldn't mention it now, but like if you are dealing with images, let's say computer vision images, yeah, which are matrices ultimately, and each pixel has particular values, and you want to manipulate an image by manipulating the pixels, this sort of functionality becomes extremely useful then. But again, this is too early for me to refer to that. All I want from you in these early sessions is to just become familiar and understand that, okay, yeah, this is possible. When will I be using it? Later on, yeah? But so long as you become familiar with it now, so when we mention it in future, you don't suddenly go, oh my God, where did that come from? Okay? That's why I emphasize that you sort of practice and become familiar with these methodologies and applications in there. Next is the linspace, which is extremely important. So let's see what does that do. np.linspace. Did I spell that right? Yeah. np.linspace 0, 10, 3. Okay. What did that do? Okay. So it picks up 3 numbers. Okay. From 0 to 10, linearly spaced out. Okay, what if I was to choose this as 20? Well, and if I wanted to choose 21, still does that, but it tries its best to create a linear separation between these 3 elements that you want to choose. All right, so I have over there numbers between np.linspace, numbers between 0 to 10, and we want 50 of them. Okay, if I do that, so you can see that it exactly does that. Just please pay careful attention. Hope you pay a note. The output is not a matrix. It's because I've had sometimes my students suddenly thinking, oh, it just created a matrix. No, it's not a matrix. It's just an array, and the numbers are packed up. They are just packed up to be efficiently visualized, in the output. A matrix, a NumPy matrix, I want you to, let me write it here, for matrix outputs, please pay attention to the brackets. Okay? And I'm referring to these brackets here. All right. So this is just basically creating an array. That's all I'm trying to emphasize. So NP linspace, again, becomes highly useful. It's a fantastic tool for future again. I mean, right now, in its current form, it doesn't make sense. That why would you want to do this? Especially when it comes to some statistical analysis stuff, yeah, it would be pretty good. Let's go next. I am hoping, because now we sort of start touching on some linear algebra, and I don't know how involved or how much knowledge some of the guys, attending the class are with regards to linear algebra. Uh, np.I basically, let's just do it so that we can discuss. np.I, so it definitely has nothing with human vision or eyes or optics, yeah. Look at that. So NPI 4 by 4. We can straight away see that this is a 4 by 4 matrix. We pay attention to the brackets. Okay, so we got one initial bracket, an end bracket. We got the bracket that defines the rows. Okay, and definitely it's 4 by 4. What if I had a 7? Yeah. So again, we got 7 elements, 7 columns and 7 rows. What is I? Notice the 1 in the diagonal part of this matrix, yeah? The diagonal of this matrix is filled with 1s. This is, in fact, an identity matrix, yeah? I'm sure those of you who know linear algebra, this is a straightforward. But for those of you who are not or never heard of what a identity matrix is, so it's a matrix of zeros, except that all the diagonal elements are 1, and it's called the identity matrix. So this generates an identity matrix with the desired dimensions. Okay, that's all it does. Now, can I do? You might be inclined to go and try, especially, I don't know, can we do that? Definitely not. Why? Well, apart from the Python syntax, yeah, there is no such a thing. You cannot have really a diagonal matrix which is not a square. Well, let's not get into that, okay? But usually you use a single, parameter to input to the I function, and it generates that identity matrix for you. Why is it useful? Is it useful at all? Well, it is when you want to do some linear algebra operations. Okay, it becomes extremely important to be able to generate this because you want to do some matrix vector operations. Now, I have prepared a list of videos on Python and linear algebra. It's about roughly, I think about 8 1-hour sessions. I'm more than happy to, from next week, to share those videos for you so that if you like, it's all in Python, just similar language, so similar basically structure, and it introduces you to linear algebra, except that we go through linear algebra with Python and Python coding. And it specifically, I'm only using NumPy for it. So yes, I will add those videos from next week onward as you're getting more sort of comfortable with, like Python, except that I need to introduce some visualization as well for you to be able to fully understand those codes. So maybe either from next week or the week after, I would extra lecture videos on the VLE that you can watch if you are interested with knowing more on linear algebra and how to do it with Python. Okay. Okay, where am I? Random. Again, another very useful functionality. Obviously, there are many things, guys, you can do with NumPy, yeah, but I'm just highlighting some of the useful tools here. So np dot random dot rand. I want you to pay firstly an attention to something. So within NumPy library, there is a module random, and we call him rand of that random. Whereas for the identity, we called it directly from NumPy. Yeah? So just memorize that for the moment. I didn't say np.rand. I said np.random.rand. Yeah. So what does this do? Okay. Well, it just generated an array again. Please make sure to remember that all NumPy associated functions output NumPy arrays for you, which is great. So we never get a list out, yeah? Or a tuple out or anything. NumPy functions are usually basically producing a NumPy array for you, okay? So what did it do? It just generated two random numbers, yeah? And if I just keep running that, every time you would see a new number coming up. But have you noticed something though? We are talking about numbers. Did you notice? These are numbers between 0 and 1. Okay? So that is if you want a vector. Now the good thing is that you can create a random matrix as well. Yeah, so you just say np.random dot rand 5, 5. Okay, and this again, pay attention to the brackets. This is not a vector anymore. Yeah, don't mistake this with if I had done I don't want to be boring, but the reason I emphasize on this is because I've noticed people making mistakes with this. So these two are not the same, yeah? This is a vector, it's just packed like this so that, it's visualized nicely. This is a matrix because we look at the brackets where every row is separated. This is simply just a long vector, right? So we can have a matrix as well. Then we need to define the dimensions of the matrix that we want these random values to be generated, and fill that matrix. There is the rand n, which again is extracted from the random of NumPy. So np.random.rand n. Okay, and let's just give 2. All right. So as you can see, it's basically creating a normal distribution. This generates usually, like you don't say random 2, like you can have more numbers, like depending on your use, yeah? But this goes from minus to plus, basically, yeah? So it gives you a wider distribution. Let me just see if it does it for you. Sorry. Okay. No, it didn't bring it. All right, cool. So again, remember this, yeah, because it will come handy in future. A lot of the stuff I'm saying at the moment might just seem nuisance, or like, why would I want to have these two random numbers? What's the point of it? Later, yeah. All I need you to do is to remember this exists, or have some vague memory of it. So if in future we do it, you don't suddenly say, "Oh, what was that? How did it drop in here?" I'm getting confused. So long as you know that this exists, that will be fine, yeah? And getting used to it and memorizing it. Finally, let's just look at the rand int. np.random.rand int, and I'm going to, okay, put 100. Okay, np.random.randint. This function, you give a start, you give an end, and you ask it basically to generate a random integer for you. Okay, so every time I run this, I would get a different value outputted, right? So you just generate a random integer from a range that you give it. If I go np.random.randint, and I'm gonna go 110. Okay, what does that give me? All right, so when I gave 1 to 100, it basically went and picked out a single number by default between 1 and 100. Whereas here, it is generating some 10 random numbers chosen between 1 to 100. And the same explanation that I gave before. If you get confused, or if you just get bothered as into, okay, what do I need this for? All of these are acting like tools that we will be using in future. All right. I'm just thinking, let me just see how much time do we have, and what did I want to do? So reshape, yeah, definitely shapes. I want you to be indexing, yeah, that's cool. Okay. Right, let me just pass this. We don't need it. Yeah, let's do that. Right. So let's make some basically, let's make some vectors, yeah, and I'm going to just copy these. So I'm going to say array equals np.arrange 25, and I hope you just quickly now remember we are creating np arrange 25. It means go from 0 to 25, not including 25. Create a vector for me with these numbers from 0 to 25. And random array equals np dot random dot rand int, and that's going to be 0, 50, and 10. Okay. And if I call them, as you can see on the slide by this, it's a ran r. Okay. So we got these two vectors, and I hope none of you, oh well, you're not asking, oh, what happened? Why are we having a different vector? Because I've been asked this actually. Why did we get a certain vector here and we're getting the, well, remember, it's generating random integers. Every time, in fact, I do this, it's going to be a different array. Yeah, we will get to sort of, how to seed this so that you would get the same random number, but that is at the moment, I'm not going to touch on that, on how to sort of set a seed for the random process. But for the moment, just remember, every time you run this, you're just going to get a random set. So what is array's shape? Let's use the shape. Yeah. So r dot the shape. What is he going to give me? Oh, this is not callable. np dot arrange. I'm getting a lot of array np dot r dot shape. Okay. I do apologize. I've noticed I'm making some silly mistake. All right. The dot shape, yeah. The dot shape returns. It returns information as it returns information regarding the shape, or other words, dimensionality of the vector or matrix. Extremely useful, that shape, yeah, extremely useful. That shape you will be using when it comes to using deep learning and machine learning. You would be using this constantly as you process your data through and you do like different operations with it, because shapes become super important. Yeah, they become super important later on, especially with deep learning and how you feed data and how you feed tensors through the neural network structures, for example. So I really want to emphasize on the importance of using shapes and understanding what these shapes are. Okay, and if I say that probably this is going to be one of those methods that you will be constantly calling, trust me, that will be the case. Yeah. So while you use shape to extract information, okay, did we have one? Let me just copy this here. So we knew that this was a np.I77, it was a 7 by 7 identity matrix. Yeah? So if I do shape, it's just returning the shape of this matrix to me. Yeah, super important. When it gives it like that, you are dealing with a vector. So it's a number line. Yeah. But when it's two-dimensional, it is going to be 7 by 7. Now, when you get to tensors, which are matrices in higher dimensions, obviously you can have different numbers here, different values associated with those particular dimensions. But for the moment, just consider a 2 by 2 matrix. So that was a 7 by 7. Now we can use the reshape function. Okay, so 25, which one have I done here? Array. So let's look at the array again. So the array is 25 numbers starting from 0. What if we want to convert this into a matrix? You do the R dot reshape. Okay, R dot reshape. So reshape it to what? Shall we reshape it to 4 by 4? No, I'm getting an error. What error am I getting? Cannot reshape array of size 25 into shape 4 by 4. Ah, so what did I do wrong here? Well, the fact is, when it comes to, although reshaping is super important, yeah, you need to be aware that you can't just reshape a vector, for example, or a matrix or a tensor into whatever you like. It needs to follow a particular pattern where the multiples of a vector, for example, the multiples of the matrix dimensions equal to the length of the vector, for example, or the multiples of the dimension of a tensor match the dimensions of a vector. In other words, if we go with this simple idea, since this is 25, the only thing you can reshape it to is a 5 by 5, because there is no other set of numbers that would give you uh, like a 25 basically once multiplied. So if I do 5 and 5, okay, there we go. We just created a matrix now. So it reshaped it. So I'm going to just put it here as well, while super important and will be used extensively in future. Using reshape requires a sound understanding of initial vector or tensor or matrix's shape and dimensionality. Right? So just put that in the comment. Right? So definitely do understand that. Yeah. Now we can also reshape matrices back into vectors. Yeah. How do we do that? I want you to figure it out. Yeah. Look at this shape. Can we reshape this back into that? Yes, we can. But go and try it yourself by trial and error. You should get it. It's quite simple. All right. Max, min, argmax, and argmin. Super important, especially when we use like some machine learning models. They give us an output, and we need to, especially for classification, when we want to convert a vector of probabilities and pick out the right prediction of a model, for example, in classification. They will be quite useful there. But what do they mean? So if I say random array, what was a random array? 40, 30, 38. Okay, cool. Yeah. So runner.max. It just goes and picks out the maximum value in your vector. Now runner dot, please pay attention, argmax. Okay, it gave 9. Do we see a number 9 here? No. What is this referring to? So this refers to the maximum, to the highest number. Okay, while this refers to the index number of the highest number. Guys, there's a big difference in this, yeah? Again, the reason that you see me sometimes emphasizing on something, for some of you who are familiar with this, you might be like, oh, okay. But for those of you who are new, you see this is position 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 44 which is our maximum value in this vector, is at position index 9. So argmax picks out and reports to you the index position of that maximum value. Now then you also have the ran r dot min, which gives you the minimum value, and ran r dot arg min, which gives out the sorry, location of the number 1. Yeah, so it goes like 0, 1, 2, 3. So position argument, sorry, the index 3, which is the position that you see in that vector. Yep. Sorry, runner is not a function. It's just a vector we created. Okay, so runner, maybe like in between you have pressed something, that has changed it. So runner was here. So if you want, just do that. Yeah, so let me come back. Yeah. So just go ahead and type this and shift enter. Ran r is not a function. It's just a random integer vector we created. Okay, so type ran r. Is that okay? You fine? Sure, just type that. Good man. No, I understand. I mean, like, I think it's getting late. And then usually once you start coding, sometimes I'll make some silly mistakes that it takes me a while, especially if I'm tired, to sort of figure out what I did. It just is that you probably changed it somewhere and then like it gives you an error. And in that moment, it becomes difficult to know what you did. Um, Let me see. So we are having a reshape here. I think I went through the reshape with you, didn't I? Did I? I did. Yeah, we did reshape. So shape, reshape. That's okay. Okay, NumPy indexing. Let's close. I was hoping to do some function practice with NumPy with you, but I think we're running out of time. So it's okay. We got plenty of weeks ahead. We will get there. Okay, indexing. So let's just make another. Let's just make another array. I don't know what was the previous array I made. Arrange. Sorry. Arrange 0 to 11. Okay, so that's my array. It's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Would it be better if I do this? Maybe. Let me see. I think that would be better if I go like that. Yeah, I think this would be a better way of explaining it than what I had here. Okay, so that's my array, guys. Yeah. So indexing is super simple. It's super simple, but sometimes if you're new to it, you need a bit of time until you get hold of it. Just like it follows the same rule. It follows the same rule as the lists or tuples, basically, when we were working with them. So if I want position 8, index 8 value. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. I want number 18. If I say r bracket 8, I get number 18. Okay. So that's a basic picking out of a single number from the vector. If I want a chunk of this, yeah, let's say from 0 to 13, so from 10 to 13, I would be like array bracket. I will do from 0 to 13, 0, 1, 2, 3. Okay, so if I say 4, okay, and it give me that chunk. But pay careful attention to what I'm about to show you. You see here, I wanted from beginning all the way to the 4th location. I can also do, yeah, Oh, when did I do that? Notice that I didn't put 0 or anything here. When you don't put anything in there, it just means that start from beginning. Here I just said 0. Well, 0 is the beginning. Whereas if you don't put anything here and you just say column up to, it means go up to position 4, which is number 13, which is 3. So this means up to 4, yeah, but not including 4th index, yeah. So start from beginning. It's very important you understand this, yeah. Whereas this says start from 0 up to 4th position, okay, and not including the 4th, of course. So you can use this syntax. Otherwise, if you want to start like from 1 or 2, you just use the number. But if you mean to like start from 0, you don't have to put it. You can just put that. Yeah. Where it becomes so, I think for a vector is quite simple. Most guys, very quickly get the hold of the idea. It only becomes a bit difficult when it comes to choosing the matrices. Yeah, when you want to index the matrices. If we do, let me see how much time do we have. Okay, let me just show you this and then we can shoot it off. Look at this slide on your own. I'm going to skip it. So we have this array, okay? And I'm assigning from position 0 up to position 5, not including 5 days, equal to 100. And that's what it does, okay? So this is like resetting or like you're broadcasting basically a value 100 to a portion or a section of your matrix. Please try to definitely practice this on your own, yeah, and understand it for the moment, yeah. And what I want you to pay attention, when you get here is that once you do this, in fact, I think this is quite important. I shouldn't skip it like this. Do you know what? I think I'm going to start next week from this section because I think it's important you understand this bit. Yeah. So I'm going to try to wrap it up. Let me just see. So we have like about 7 minutes. If I want to cover those. Okay. Yeah, I think we need to come back to NumPy next week again. I tried my best to try to fly over it, but I have a feeling that we need to dedicate time to it. So for next week, we start with NumPy. Okay, so for next week, we start with NumPy so that I cover these bits. And then I will cover pandas data frames. Now, pandas would enable you to open data sets like Excel sheets, CSV files mainly. That's what we will be working. So pandas enables you to work with those data types, import the Excel sheet and or like data in form of Excel sheet and try to manage data frames. That's what we will be doing next week. But because I feel I need to complete this. We will give a touch on this. All right. In the meantime, I would appreciate it if you look at these slides and try to make sense of it, especially with this copy bit. Yeah, very important. You see, I have reassigned a certain section of this array. Okay, but when I even go and rename and try to sort of I'll leave it for next week. Yeah, I will cover it all next week. No point in basically trying to talk about it now. All right, guys, I'm gonna now let you go because I'm super tired myself. I had a lecture this morning and then I had some meetings one after another. So I'm a bit dizzy right now. If you don't have a specific question, I'm gonna say bye for now. Otherwise, if there is any other things, other issues, please drop me a message or an email and I will respond to you. Is that okay? No problem. Thank you very much, guys. No problem. It's fantastic. I do apologize. I feel I was a bit tired today. Maybe I lacked a bit of energy. No problem. Thank you for your interest, guys, and see you next week. Yeah? And I will put the recording of the lecture and everything later on. Thank you so much. And take care, guys. Bye bye. Bye bye.